For this video, I've created a new project called File Listings. I'm just going to jump right in and show you some other very useful methods on the Files class. These are list, walk and find, all which are methods that can be used to get a source for a stream pipeline of path elements. I'll start by creating a path variable named path. Remember that if I create a path with an empty string, this is the current working directory, which is what I'm doing here. I'll print the full path of my current directory using the toAbsolutePath method on the path interface. A very common need is to understand what the contents of a directory are. Maybe you've used the dir command on Windows or ls on Mac or Linux. This is the same concept. The files class has a list method, and as usual, it takes a path instance. This method returns a stream of path instances, each path representing either a file or a subfolder in the directory I specified. Next, I'll create a local variable, and that's going to be a stream, typed with path and called paths. I'll assign this the result of calling the static method named list on the files class, passing it my path instance, and that's going to return a stream of type path. Now here again, you can see I can't use this method without either catching or specifying an IO exception. I will surround it with a try-catch using IntelliJ's help. I still have a warning though on the list method, which I want to look into further. Hovering over that, IntelliJ tells me that stream is used without a try with resources statement. Why is IntelliJ giving us this warning? We didn't see it for other methods on this class, like writeString or readAllLines for example. What's happening with this method? Don't forget a stream is lazily executed. This means a reference to an open directory is maintained after this call and remains open until the stream's terminal operation is executed. Sometimes it's easy to forget the methods that return streams are opening a resource. Other methods, like readAllLines for example, are both opening and closing the resource for you as a convenience. You should always use a try with resources statement for the list, walk and find methods that return these streams of paths. Again, I'll use IntelliJ to assist me with making the change to try with resources. First, I'll undo what I did earlier, removing the try catch. This time, I'll place my cursor or hover over that method name list and use the key combination Alt-Enter for Windows or Option Return for a Mac. From this dialog, I'll select Surround with Try with Resources block. I can't actually stop there though, since I still have to catch an IO exception. I need to add catch clauses, and I can preview the generated code in that dialog. I'll select that option. Okay, now I can start adding code in the try block to actually do something with this stream of paths. In this case, I'll add a single statement, the familiar for each terminal operation on the stream called paths here. I'll call for each, printing each path. Let's run this to see what output we get. I'll see all the folders and files in my current working directory. This method isn't recursive, so I won't see the content of any subfolders. From this listing, the only way to tell if it's a directory or file is by observing that files usually have file extensions, but this isn't a rule you can depend on. I'll create a private static method next that'll use attributes from each path instance to print a friendlier directory listing. I'll call this method list dir, and it'll take a path, returning a string. I'll start with a try block because some of the methods I want to use throw a checked IO exception. I'll use the files .isDirectory method, assigning that to a Boolean variable I'm calling is dir. If there's an IO exception for any statements I call above, I'll print something went wrong, and I'll simply return the path as a string. I'll use my Boolean variable to determine what gets printed, outputting different information for a directory item versus a file. Before I do that, I'll get the last modified time. In an earlier video I mentioned that there are multiple ways to get data about a file, either by calling getAttributes or getAttributeOnFile. A simpler way is just to get last modified time. I'll use file time as the type and date field as the variable name, and then call files.getLastModifiedTime. I'll return a formatted string. My first field will be last modified time. Here I'll just use the %s modifier because I'm going to pass the date field as is, so the toString method will get called on this field. If the path is a directory, I'll include dir in angle brackets And lastly, I'll print the string representation of the path. Getting back to the main method, I'll now include a map intermediate operation in my stream pipeline. I'll add a new line before the dot for each. Now I'll insert the map operation that will call my list dir method. I'll pass this as a method reference to the method I just created, so main : list dir. This will transform my path to a string, running this code. My output is looking a little closer to what a Windows directory listing might look like. I can easily identify a directory now. Notice the dates in the output, they end in Z. Remember, Z is code for UTC, date and time. For the average user, this would be confusing to see, so it would make more sense to show them their local date time. I'll refine my listing method to do this. I'll reformat the date and time here, and including the size of the file. I'll start by setting up a local datetime variable, mod dt. I can create a local datetime out of an instant and a zone ID using the ofInstant method. The file time type has a toInstant method on it, so I can pass that as the first argument. Next, I can get the local zone from zoneid.systemDefault. I'll also change the formatted string for the output. First, I'll add two datetime specifiers. I'll replace the first %s with %td for date and add a %t capital T for time after that. Next, where I have date field, I'll replace that with mod dt, but I need mod dt in there twice. I could change my formatted string to include argument indices, but for now this is just simpler. Before I run this, I'll also include file size if it's a file. First, I'll change the -15 in my output to -5. This is left justifying. My datetime fields should all be the same width now, so I can adjust for just this field size. I'll add %12s after that. For the size, this is right justified and allows size a maximum width of 12. Next, in the arguments list, I need to include the size for files only, so I'll include a ternary operator before the last path argument. If it's a directory, I'll return an empty string. If it's a file, I'll return the size variable, and I'll get that with a call to files.size, passing it path. Let's review the output with those changes. You can see that the date and time is now nicely formatted for local date and time, and I have the file size in bytes of my two files in this directory. This code gives you one example of how to use path data and the list method to give your user information about a single path's components. There's another method on files that's similar to list. This one is called walk. Let me set this up. I'll first print a separation line to split the output in the main method. I'll copy the entire try-catch block that uses files.list and paste a copy below my separator line. I'll change the method from list to walk, and I'll add a second argument, an integer, which I'll just make 1 to start. I'll explain this in a minute. Running this code, I get the same output using either walk or list. The significant difference between these methods is that walk is recursive if I specify a depth greater than 1. The second argument in the call to the walk method is the depth, so now I'll change that to 2. Let's see the output. The code is now walking through the subfolders of the original path, which was the current working directory. The output is now showing us the contents of the .idea folder, the out folder, and the source folder, not going any deeper than that second level. I can use my stream pipeline techniques to filter out directories and just list files. I'll add this filter first before the map operation. I'll filter by using files : is regular file. Running this code now. I only get a list of files up to 2 levels deep from the current directory. I could continue to filter and alter the depth to find a specific set of files with a single extension or name, for example. But actually the files class has an even better method for this kind of operation, and that's the find method. This is basically like the walk method, but you can specify your condition as an argument, which is more efficient. I'll copy all the code, including the separator line and the code below it. I'll paste that copy at the end of my main method. In this last block of code, I'll change walk to find, and I'll insert a comma and a new line after the number 2 there. The third argument is a by predicate type. Hopefully you'll remember that by means it takes 2 arguments and predicate means it returns a Boolean. The first argument is the path itself, and the second is a type named basic file attributes. You can think of this second argument as providing you with convenient access to all the attributes on your file or directory. Whether I actually make use of both arguments in the expression is up to me, but I do need to include both when I define the Lambda arguments. Just a reminder, whenever I have two arguments, I need to include parentheses around them. Here, I'm going to call the path variable p, so it won't conflict with the path variable I already have. This p variable represents each stream element. Next, I have the attributes data for each path, so I'll shorten that to ATTR. I can make the expression anything I want. First, I use the same filter operation as the walk statement, checking if the path on the stream is a regular file by calling isRegularFile on the files class, passing it p. Finally, I can simply remove the filter operation from my pipeline. Let's see the output now. My last block of output will look like the output from the previous walk code. That's nice and all, but why not just use walk with filter, which seems a little easier to understand? Let's keep going and change this Lambda. First of all, I don't have to use files.isRegularFile at all. I can use the attributes of the path, which are available to me here, in an easy-to-use way to filter instead. I'll replace files with my argument name ATTR. I don't have to pass an argument because this attribute is already associated with the current path in the stream. Running that, I get the same output. Let's have a bit more fun. First, I'll look more than just 2 levels deep. A common approach is to put integer.maxValue as the depth there, so it will search all nested levels. Next, let's find files that are at least 300 bytes in size. I can do this by checking that variable ATTR being greater than 300. Running this code, I get both my class and Java source files, which have met this criteria, as well as some of IntelliJ's project XML files. You can imagine using this method to search for any files modified in the past week or any files that exceed a certain size and so on. There's one more method of files, which I'll show you next, which can be a bit more efficient. First, I'll print out a dividing line with a header that says directory stream. Directory stream is another Java NIO2 class. It provides an iterable for directories. Like the others, I'll put this in a try with resources block. I'm going to use var here, the variable name dirs, and set that to the result of another method on files. This one is called new directory stream and takes a path. Because the result is an iterable type, I can use for each on it, and I'll print each item using main.list dir to get the usual directory listing string. I also need to catch an IO exception. Let's see what that gives us. I get a directory listing of my current working directory. This method has an overloaded version that lets us filter which paths we want back, first with the use of a string called a glob. A glob is a limited pattern language that resembles regular expressions but with a simpler syntax. You can see these at the URL shown on this slide. I'll pull that URL up. Here, you can see some of the string patterns we can use to match on a file name. To show you this call, using a globbing pattern, I want to first change the directory I'm starting at. I could use one of the path creation factory methods, but there's a method on path that will let me navigate from the path I'm at to another. This is called resolve, and I can pass it the name of a subfolder. In this case, I'll pass it .idea, so IntelliJ's project configuration folder. I'll include the glob*.xml as the second argument to the new directory stream method. Running this code now, I'll only get files that end in .xml. Okay, so that method's pretty easy to use, and the glob is probably something you might already be a little familiar with. There's another overloaded version of this method that takes a type that's on the directory stream class, and that's a filter, a functional interface. This means it's a target for a Lambda. It takes one argument and returns a Boolean. I'll copy the code, starting with my header there, and paste a copy just below. I'll delete the string with *.xml there, keeping the comma and inserting a new line. I'm going to include my Lambda on that empty line, which will work like the glob. My Lambda takes a path, so I'll get the last part of the path, file name, with a call to get file name, and I have to make that a string because it actually returns a path. Then I'll call ends with here, passing it .xml. Running this code, I get the exact same results as before. However, I can make this lambda be anything I want. So here, I'll add that I only want regular files, and let's say I only want ones that are greater than a kilobyte. I'll enter 1000, which is actually slightly less than a kilobyte, which is 1024 bytes. Let's review the output. I get only one file back now. This method probably reminds you of the filter method, except it doesn't include depth. Another important thing to note about this method is that the elements returned by the iterator are in no specific order. These methods make it pretty easy to walk the file tree or list data in directories. If you've examined the Files class API closely, you'll have noticed there's also a walk file tree method. I'm going to give you an example of this method next. Because it's not so straightforward, I think it warrants a little extra attention. Since this video is getting a bit long though, I'll do that in the next video.